I will be making a video of question 2 from homework 6 of probability and stochastic process. In this, fxy of x comma y is equal to b, x square plus y square less than equal to 1, and it's 0 for otherwise. For the first part, we have to find b so that the above defined function is a valid joint probability density function. For the first part, it's given that fxy x comma y is equal to b, and since taking the volume b dot pi r square is equal to 1, given that r is equal to 1, b is equal to 1 by pi square. And for the second part, we have to find expectation of x, expectation of capital X given small y, expectation of capital X given capital Y, expectation of capital Y, expectation of capital Y given small x, expectation of capital Y given capital X, and expectation of xy. Firstly, we will find expectation of x, which is equal to double integral from minus infinity to infinity x fxy x comma y dx dy. Solving this, 1 by pi, taking integral minus 1 to 1 x, integral from minus 1 root 1 minus x square to root 1 minus x square dy dx. Next step, 2 by pi, integral minus 1 to 1 x root 1 minus x square dx is equal to 0. Since expectation of x is equal to 0, so expectation of capital X small y is also 0 for every y. So expectation of capital X given capital Y is also equal to 0. And we get the following curve f of y given x. Since due to symmetry, expectation of y is equal to 0, so expectation of capital Y given x small x is also 0, and expectation of capital Y given x is equal to 0. So we have to find the value of now expectation of xy, which is equal to 1 by pi, integral minus 1 to 1, taking integral from minus root 1 minus x square to root 1 minus x square xy dy into dx, 1 by pi minus 1 to 1 x, integral minus root 1 minus x square to root 1 minus x square y dy dx is equal to 0. Expectation of exy is equal to expectation of exy given x, which is equal to expectation of x, expectation of y given x is equal to 0. Since it's given that expectation of y given x is equal to 0, so expectation of exy is also equal to 0. That is, expectation of exy is equal to expectation of ex into expectation of ey. So we conclude that x and y are uncorrelatable. We have, for the third part, we have to prove that x and y are uncorrelatable. Fx of x is equal to integral minus in root 1 minus x square to root 1 minus x square fxy x comma y dy is equal to 2 by pi root 1 minus x square for mod of x less than or equal to 1, and it's 0 for otherwise. Fy of y is equal to 2 by pi under root 1 minus y square for mod y less than or equal to 1, and it's 0. Fx of x dot fy of y is equal to 2 by pi root 1 minus x square 2 by pi root 1 minus y square, which is not equal to fxy of x comma y. We conclude that x comma y are not independent. X is equal to minus 1. We must have y is equal, so y is equal to 0. Hence x and y are not independent. Thank you.